Hi, how's it going? Welcome to Code with Z. Today's question is LeetCode number 40, combination sum, part 2. Now, I want you to know that I'll explain and visualize everything in the coming slides, but for the sake of reading the question, let's see what the question is actually asking us for. So as you can see, we're given a collection of candidate numbers called candidates and a target number that's called target, shocking, and we need to find all of the unique combinations in our candidates where the sum of the candidates are actually equal to our target number. But each number inside of our candidates has to be only used once, and this makes it different from the previous question that was combination sum part 1. Now, what does all of this even mean? Well, if we check our examples here, this is our candidates array, for example, and this is our target number. Currently, our target is 8, and our output, basically the thing that we gotta return, is 116, and if you check, the sum of these numbers are gonna be equal to our target number, and we've only used each number once. And you might ask, we have two ones here, Z. Well, yeah, you're correct, but we also have two ones inside of the array itself, so we can actually use one of them each time. And if we check the other answers, 1 plus 2 plus 5 is equal to 8, 1 plus 7 is equal to 8, and 2 plus 6 is also equal to 8. So how should we solve this problem? I'm glad you asked. This is our candidates array and this is our target number, and because we need to find all of the combinations of these numbers that are going to be equal to our target number, and the fact that the length of our combination was not even determined by the question, for example, 5 by itself can be an answer and that's equal to our target number, and 2 plus 1 can also be an answer and that's going to be equal to 5. So because we have this situation, that means we have to explore all of the possible scenarios. Every time we say all of the possible answers and all of the possible scenarios, the name of backtracking shines. So we're going to use backtracking because backtracking is going to help us to explore all of the possible answers. Now I'll explain you the structure of the algorithm and then I'll visualize the whole process so you can actually get everything intuitively. So in the beginning of our algorithm, we're going to start with the first element inside of our array and we're going to check if that's equal to our target. So we're going to be like, check if we hit the target. If it is, that means this is our answer and we're just gonna add it to our results. And this is step 1. We only have 2 more steps. The second step is that we're gonna stop if remaining, meaning our target minus sum, our target minus the sum of the combination that we have here, is negative, because that means our current sum is gonna be greater than our target. So that means we don't have an answer and we're just gonna stop. And this is our second step. So if we didn't actually hit the target and our sum was not greater than our target, we're going to have our third step, which is our final step, and we're going to be like, let's explore next options, but we're going to skip duplicates. Now, let's visualize this, but first, because we want to skip duplicates, we have to sort our array. If we actually sort it, you're going to see that all of the numbers that are like each other are going to be standing next to each other, and that's going to make checking for duplicates really easy in our algorithm. So this is the same array as the previous array, we just sorted it like this. Now I'll bring these two here so you can actually have more space because I'll visualize literally everything, and this is the algorithm that we had. So for starters, we're going to start from an empty array because we don't have an answer and we're currently looking for answers. So this is going to be our result. Literally, if we don't find an answer, we're going to return this. Then we're going to be like, all right, let's see what will happen if we start with 1. Is 1 equal to our target, which is 5? As you can see, we're literally following this algorithm here. Did we hit the target? Well, 1 is not equal to 5, so no. So is 1 greater than our target? Not really. So we're not going to stop and we're going to explore other options. So we're going to be like, all right, let's see what will happen if we try 2. Well, again, we're going to check. Is 2 equal to our target, which is 5? Not really. Is 2 greater than our target? Nope. All right, let's explore other options, but we're going to skip duplicates. And if you check, the next option is 2, and we've already explored 2. If we literally add another 2, we're going to ask the same questions and we're going to have the same answers. So that's going to be a duplicate, and we're going to skip this one. And when we actually get to this one, this is going to be also 2. So we're going to skip this one as well, and we're going to get to 5. And we're going to be like, is 5 equal to our target? Well, would you look at that? It is. So this is going to be one of our answers. And we're going to add this here. Then we're going to be like, all right, we still have these 2 that are not greater than our target. So we need to explore next options. So we're going to be like, all right, we know that 1 by itself is not equal to our target, but we can actually add other numbers to it so we can actually have a greater combination. So we have to combine 1 with the numbers that we have here, but we got to remember that we can only use each number once. So we can use 1 with itself, so you have to actually start from 2. So we're going to be like, what will happen if we actually check 1 and 2? Well, the sum of this is going to be 3. Is 3 equal to our target? Not really. Is 3 greater than our target? Nope. So the sum of this is not going to be negative because we're going to be like target, which is 5, minus sum, which is 3, Is this negative? Not really, so we're not gonna stop. And we have to explore next option. So we're gonna be like, all right, what will happen if we try 1 with 2, but we've already had 2 here? So we're gonna explore next options, but we're gonna skip duplicates and we're gonna move to this one. And this one is also 2. It doesn't make sense to check it again. It's a duplicate. So we're gonna also skip this one because we skip each duplicate and we get to 5. And we're gonna be like, is 1 and 5, meaning 6, because 1 plus 5 is 6. Equal to our target? Not really. Is it actually greater than our target? So is 5, which is our target, minus sum, which is 1 plus 5, that's 6, is 5 minus 6 negative? Well, yeah. So we're gonna stop and we're gonna ignore this path entirely. Then we're gonna be like, all right, let's explore this one. Let's combine this 2 with the numbers that we have here, but we can't combine 2 with itself because we've already used it and we can only use one number once. And we can't combine 1 with 2 because that's gonna give us a duplicate. 2 and 1 and 1 and 2 are literally the same thing. And we've already explored this possibility here. So if I combine 2 with 1, it's gonna be equal to this one because we're not looking for permutations, we're looking for combinations, and all of our combinations have to be unique. So we're gonna be like, all right, each time when we try to come up with a combination, we're gonna ignore the number itself and all of the numbers that come prior to it. So we're gonna be like, all right, let's combine 2 with 2. Like so. And this is completely acceptable because we've used this 2 once, and we're using this 2 once. And nowhere else we have 2 and 2. So this is unique and we've used each number once. And then we're gonna check, is 2 plus 2 equal to our target? Well, 2 plus 2 is 4 and our target is 5, so no. And is 2 plus 2, which is 4, greater than our target? Not really. So you have to explore other options. So we're gonna be like, all right, let's combine this 2 with this 2 here, but that's gonna give us 2 and 2. We're using each number once, but we've already explored 2 and 2. So this is gonna be a duplicate and we're not gonna explore it, and we're gonna move on to the next one, and this time we're gonna combine 2 with 5. Like so. And then we're gonna get the sum of this. 2 plus 5 is equal to 7. Is 7 equal to our target? Not really. So is 7 greater than our target, meaning is 5 minus 7 negative? Well, yeah. So we're gonna ignore this entirely, and I'll bring this here so we can actually have more space. And let's bring this one here as well. Now we're gonna be like, all right, let's explore this one further. We're gonna be like, we have 1 and 2. So we've already used 1 and 2 here. We can still use these 3 numbers that are remaining. We're gonna be like, all right, we have 1 and 2. Let's combine it with another 2. And this is gonna be both unique, and we've used each number once because we don't have 1, 2, 2 anywhere else, as you can see. And we're gonna be like, is 2 plus 2 plus 1 equal to our target? Well, yeah, this is actually equal to our target. So this is gonna be one of our answers. And we're gonna be like, all right, let's explore other combinations. So we've already tested 1, 2, and 2. Let's test this one. Oh, that's gonna give us a duplicate because we've already tested 1, 2, and 2. So we're gonna skip this 2 here and we're gonna move on to the next number, which is 5. And we're gonna be like, is 1 plus 2 plus 5 equal to our target? No, really. And then we're gonna be like, all right, is target minus 8, which is the sum of our numbers here, negative? Well, yeah, 5 minus 8 is gonna be a negative number. So we're gonna stop and we're gonna ignore this entirely. And then we're gonna come here and explore this one, and we're gonna be like, all right, so we have used this 2 and this 2. Let's explore another one. We can actually use this 2 as well because we've never explored 2 and 2 and 2 anywhere. And then we're gonna check if we hit the target. Well, the sum of this is gonna be 6. 6 is not equal to our target, so no. And then we're gonna check if 5, which is our target, minus 6, which is our sum, is negative. Well, yeah, 5 minus 6 is gonna be negative, so we're gonna ignore this entirely. And then we're gonna be like, all right, we explored 2 and 2 and 2. Let's explore 2 and 2 and 5. And we're gonna check is 2 plus 2 plus 5, which is 9, equal to our target, which is 5? Not really. And then we're gonna check if target, which is 5, minus 9, which is our sum, is negative. Well, yeah, 5 minus 9 is negative. So we're gonna ignore this entirely as well. And because we've explored all of the combinations, we're gonna be like, all right, we only have these 2 answers, and that's gonna be it. Now let's code this in the simplest way possible. Alrighty, so the first thing that we're gonna need is gonna be a result variable, so let's define it. And this is gonna be equal to an empty array, because if we check, our answers are gonna be inside of an array. As you can see, all of the answers that we found are inside of this array here, and this array that we just defined is gonna be that array. Then below this, we're gonna define our backtracking function, and we're gonna call it backtrack. And this is gonna take 3 inputs, and you already know the first one, and this is gonna be remaining. And this is our target minus sum. that we checked every time. And the next input is gonna be start. This basically tells us which one of the candidates we should actually start from because we don't want to have duplicates. For example, if our start is pointing to this, we're going to explore the combinations from this point. And then we're going to have our path, which is basically the path we took to find the answer. Then we're going to enter our function and we're going to check first if we actually hit the target, just like we had it in the slides. So we're going to say if remaining is equal to 0, that means we have an answer, because this means target minus sum is equal to 0, because, for example, if our target is 5 and our sum is 5, 5 minus 5 is equal to 0, and that means we've hit our target. So we're going to be like, all right, add that to our answer. So we're going to be like result dot push, and we're going to add the path that we found. Then we have to check if our sum is greater than our target. So we're going to be like, else if remaining is negative, return, because that means we don't have an answer and we're gonna stop, just like we saw in the slides. And then below this, if we didn't actually find the answer and our sum is not greater than our target, we have to explore other options while skipping duplicates. So we're gonna be like, all right, let's define a for loop like so. We're gonna say let I be equal to start, and you're gonna see why in one moment. We want to keep on looping as long as I is smaller than our candidates, like so, dot length, because we want to loop through each number that we have, and then I++ on each round. Here we're going to be like, for example, if we're adding 2 to our path and we're checking what will happen if we start from 2, just like we saw in the slides, we need to actually add it to our path, right? Because we're actually checking what will happen if we add this to our answer. So we're going to say path dot push candidates at the index of I. We're literally saying add the candidate at the index of I to our path, and then we need to check what will happen. So we're going to call our backtracking function to check what will happen. We're going to be like, all right, this time, because we've added this candidate to our path, our remaining is going to be remaining minus candidates at the index of I. This is literally saying, because we've added this number to our path, subtract that from the remaining and check if we have an answer. And then we need to give it a starting point, because this is what our backtracking function takes. And if you remember, each time we were like, explore all of the numbers that come after the number we're exploring. So for example, if we started with 5, we don't want to check 5 itself, and we don't want to check all of the numbers before it. We only want to check the numbers that come after it, just like we saw in the slides. So we're going to be like, start from I+1. And this is basically like saying, start from all of the numbers that come after 5. And then we need to pass our path, which is basically our path that we just modified here. Then this function is going to explore that possibility, and it will update our result if we actually find an answer. So then we're going to actually loop, and we're going to get to the next round, and we want to explore another number. So before that, we need to actually pop the number that we added previously. So when we get to the next round of this loop, our path has the correct numbers inside of it. Each time we're going to be like, add this number to our path, explore what will happen, and then empty our path and check another number. Then explore that one again, and again empty it, and move on to the next number. But as you can see in the question, we can only use each number once. So for doing this, we're going to be like, all right, we need to know which numbers are equal to each other, and we need them to stand next to each other. So for doing this, we're going to first sort our array. So candidates is equal to candidates dot sort A and B, and this is basically just how we sort arrays inside of JavaScript, like so. Let me add a space here. This sorts our candidates array. And here, we're going to be like, all right, we know, for example, if we have 3 2s, they're going to be standing next to each other. So we're going to add an if statement, and we're going to say if candidates of I is equal to candidates of I minus 1, meaning if the current number is equal to the previous number, continue. And this basically means that we're going to skip everything and we're going to get to the next round, because our current number is equal to the previous one, and we've already checked all of the possibilities for that number in the previous round, so we don't need to check it. But if we are in the first round of our array, I minus 1 does not exist because it's literally the first round. So we need to say only check this condition if it's not the first round. So let's do that. First of all, let me drag this to the left, and we're going to say only check this condition if I is greater than start. Now, this is going to be our backtracking function, and now we need to call it for the first time. So the first time that we're going to call it, our remaining is going to be target, because we have nothing in our answers, and target minus sum is going to be target because sum does not exist. So we're going to say target, that's going to be our remaining input here. Our start is going to be 0 because we're going to start from the first element inside of our array, and our path in the beginning is just gonna be an empty array. Now let me zoom out a bit. After we've called this, our result array, which is this array here, is gonna be filled with answers, so we need to return our result, like so. However, when we actually push our path to our result, we need to make a copy of it, because each time we're gonna modify our path, and when we find an answer, we need to copy that inside of our result. So I'll just make a copy of this, like so. This is basically adding a copy of the path to our result and not itself. And this is gonna be all of our code, but I made, I think, 2 typos here. This has to be backtrack, and this has to be candidates, like so. Now, sorry for that. Let's run it and see if we're gonna pass our tests. Yep, as you can see, both of them are passed. Now, let's submit it. Moment of truth. Drum roll, please. I'm just kidding. Let's see if we're gonna get accepted. Yep, and we're beating 68% of all of the other submissions. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.